Okay, we have seen model view. We have seen the very simple view. I talked to a few people up here that said, well, we have this problem with our application. It was using Q-standard model, and obviously by now that person hopefully understands that that's not exactly a good idea, because with Q-standard model, you're giving all your data to the model. It is tempting to use Q-standard model because it's pretty easy. Hopefully you guys have learned enough about model view now, so you can use a list and a table model the way that they are really efficient, namely as a very thin layer accessing your data underneath. There is a special case of these models that's for tree models. I would use the Q-standard model. I'm afraid to admit here. I would use the Q-standard model if I just had like a couple of hundred items in my tree model, because what I'm going to show you now is going to be more complex. So please, when you see the next half hour or whatever it'll take, please consider again and again that you have some data structures that are really, really expensive. This is not just the countries at the topmost level, and underneath you have the cities. This is this model that we're going to show you now, the tree model here. It's a tree model where at the topmost you have all the countries in the world, and then you can click on one of the countries. Then you will see all the cities in that country. Then you click on a city and you'll see all the streets in that city. You click on a street and you'll see all the houses on that street. You click on a house and you'll see all the inhabitants in that, or all the IP numbers of things in there. You click on these and you'll see, and you'll just very deep think of something that would take you days to populate regular way. It's on demand. Just don't get me that data before I need that data. That's if you get into that mindset, you'll understand all the complexity that we're going to talk about now. If you only have all the countries, and underneath the countries you have the cities of your most important clients, and in total it's going to be 200 items, go for Q-standard model. This is for the real hardcore stuff. Tree models.
Right, so we saw abstract list model, abstract table model before the break. Everything we've implemented there is also applicable to tree models, so we need row count, column count, data. But now we also have to actually look into the parent index argument we get there, because row count now, of course, is different for each hierarchy level we are looking at. So besides making the already existing methods slightly more complicated, we also have two new virtual methods that we have to override, which for the simple cases is done in table and list view, list model already for us. And that is index and parent. Index, we saw that earlier in the examples on how we actually get a model index. That's a method that gives us a model index valid for this specific model. And we pass in the row and column index and the parent. So just by cascading those, we can get a QModel index instance for every cell in the model, and then we can call data and so on with that. So that's for navigating down the tree. And then we have parent, which is the other way around. So we have a model index and we want to figure out what's the parent model index, navigating out of the tree again. Now that might look kind of surprising, because we saw earlier that QModel index has methods for exactly that already, right? So there's QModel index parent and QModel index index. So we can just call those and be done with it, right? Unfortunately not, because what QModel index will use to implement index and parent is exactly those methods of the model. So we are the ones that actually have to do the work there. Yeah, if we are supposed to hand out a QModel index, then of course someone needs to tell us how to create them. And that's why there's a protected method in abstract item model called createIndex. That's what we will be using to create a model index valid for this specific the specific model, and that will also allow us to embed some internal information to make the following a lot easier.
Easy, right? Just implement two new method.
Yep.
One is called index, the other is called parent, and you need to create a QModel index, and you'll just do that by calling create index.
Yep.
That's the method. Okay, good.
How hard can it be?
Yeah, we need to clear this room because the party seems to be in here tonight, right? No? Okay.
What?
Okay, I guess it's not that simple. Let's try this out. I would like to just do a small game here with Volker, just to show you how this stuff works. I will. Can I get the pens again? Hope you all can see. Zoomed in there. Awesome. Okay, so we have a QModel index. These QModel indexes, remember, I was standing over here an hour and a half ago. I was standing over here. I was drawing this tree that Volker had over there. Instead of asking the A underneath the B underneath the C and so on, we had a model index for this communication. And these are the model index that you are to create now. So a model index represent an item. That's the first thing. So I'll have a QModel index here. My QModel index. Hang on a second. Never mind. That's not the. Got confused. So basically, what we will be doing here now is that I will again query this information. I'll show you this time with the QModel indexes that is inside the with the new QModel indexes, those that Volker will be creating. Volker is a model. I'm a view. Volker will now sing for you while I draw this here. Right, said Fred. I'm a model.
Nah, not really. You don't want to hear that.
So QModel index has 3 parameters. It has a row, it has a column, and it has either, as we saw, an internal pointer or an internal ID. The internal ID is for like if you have something as a map, then you can use the ID as an index, or the internal pointer that is a pointer to some real data structure. Remember, the model indexes are like a fart. You don't keep them around for long. So when I ask for a model index for this one here, it should always give me the same model index. So it has a row, column, and pointer. OK, let's try this out. Here is a small game. Let me just go over here. Next slide. I will show you that with this API that we have up here, that I can now draw the exact tree that we have over there. And I'll be same game as we did before. This time I'll just be a bit more accurate in how I'm asking for the information. These fellows over here, they are not, you might think they are just they are just regular pens, but they are not. They are model indexes. And we have a special model index, this one here. This is the only model index I can create. This one is called QModel index, parenthesis open, parenthesis close. The topmost, the invalid QModel index, I can create that one. All these model indexes are Volker's. There you are. He can only create those model indexes. So let's see what's happening here. I want to draw that tree up there. I have that API up there. What would be the first thing I want to know? Obviously, how many rows there is in this tree that he has. And just in case it isn't obvious, he has 2 rows here at the top, and one of them has 2 children underneath. So I will go like this. I will say, Volker, can you tell me row count?
Invalid. 2.
This is the topmost one, and let me just draw that one for you. That is the parent of all the other ones. So I'll say, Volker, row count. And he will say 2. Now I'm already ready to draw over here. I know that I should ask twice for how many children he has at the top. So I'll say, Volker, I would like a model index at row 0, column 0, with this one being the parent. So I'm asking for an index, row, column, and a parent index. I just gave him that thing, and I said, can you give me a model index for that thing? A model index representing that cell that I'm talking about. And he gave me a model index back. And he explicit hold his hand like this, so I can't see the color of his pen. That's the magic here. This is a model index, and I'm ready to rock now. So I'll say, Volker, with this model index, what is the, I want data now. Data, that model index, the role is the display role.
That's top 1.
Top 1. Awesome. I'll keep on to this because I think I'll ask for something more. Volker, I would like some more data. This is your model index. Can you tell me what is the text color?
Black.
Awesome. Volker, data again. This model index, what is the font? That's where
Jesper
he'll say
style.
Jesper unreadable. Thank you. Awesome. Okay, I know at least that I should write top 1 in a Jesper unreadable font black here. And I happen to have this is not the model index, that was the pen that I was using. Confusion. Okay, so Volker, I would like to know what is the row count for this model index.
That's 2.
Row count, model index, and I gave him this, this model index. 2, awesome. Can you give me a Q model index for row 0, column 0, this parent?
Here you go.
And Volker, can you give me the display role data for that one?
Child 1.
Child 1. The color for this, and so on. Okay, let's try this again. Notice, I am asking, just get your black model index here again. I'm holding like this. I have no idea what Volker, how he does his magic. And this is, everybody's like, wow, they can do mind reading. That's how we do it. But Volker is cheating on his mind reading. He is doing like this. So every time he's about to look at something, show you the trick. He's looking at the color of the cap here. I guess you didn't see that, did you? He's looking at the color of the cap. That is his internal pointer. Of course, that's in real world, it would not be a color of a cap. It would be 0x. What's that again? FA11 FE1.
Right.
Falafel. It would, of course, be an address in memory where he had whatever data this is really about. That's what I was about to draw over here. This thingy here, in a bit more realistic setup, it could be something looking like this. It would be a group box, and I'm just imagining a model representing my layout as parent-child relationship of my widgets here. So it could be a group box, and he had some radio buttons in here, and his internal thingy here would be a pointer to that group box. When I said, can you please give me the whatever, he would just go to that group box, which would be a Q object pointer, and do something with it. When I had another of his magic secret pens here, and I wanted to know something, he would just go and address that one. What are we talking about? We're talking about pens, right? No, we're talking about that magic Q model index up there. Volker and my communication is working because he has some internal data structure that he can look up his data in the real data structure. Remember, the model do not have the data. It's just some interface that can get to the real data underneath. If that's a TCP connection to Denmark, or if it's a SQL database or whatever, that doesn't matter. It's just the model is a layer that can translate questions to answers from down there. And for each of those, our communication token is a QModel index. You saw the API up here. Can I get a QModel index for this? Can I get data? Can I get row count? Can I get column count? I have a model index. I just want to draw stuff. I need to know the hierarchy when I'm drawing upwards. Can I get the parent? And all these questions are around this QModel index. Why didn't they just made all these QModel indexes be void pointers?
Well, it's kind of dangerous to work with raw pointers. And that also explains what we mentioned earlier, that there's QModel index, which you shouldn't keep around because it contains raw pointers to my internal structures, and persistent model index, which you can keep around because it's safely updated whenever the model changes. And I think this now explains it, why you shouldn't keep around the QModel index. Because obviously, if you do, the model might access its internal pointers, still assume it's valid, and access wherever that points and crash. OK, let's try this one more time. Volker gave you the abstract description of this. I gave you the weird description with pens that were really model indexes. Let's try to implement all of us together. Volker will be typing. You'll be shouting suggestions to him. Let's implement an example. Can we just see the solution? The
first?
Solution for the
solution
tree,
for this exercise.
For the tree or for the table?
For the tree.
OK, so we just look at that. Yeah.
No, just not the. I want to run the solution, not see the code. That's cheating.
OK.
Your eyes is getting heavier and heavier again, huh?
OK, run the solution.
That is a very beautiful user interface I created there on the left. It's a, if you can't see what this application is about, I won't tell you. It is some application. I did it in Qt Designer, just drag and drop something in there. What you'll see on the other side, this stuff over there, is like an object inspector. It is telling you the data structure of the parent-child relationship in that other thing. So can you resize the columns a bit so we can see more of the class name?
I'm trying.
Yep. So we can see that we have a Q double spin box. And the Q double spin box obviously have a Q line edit inside it. And that Q line edit has a transition with it, whatever that is. And there's we can see the whole parent-child relationship of that tree. First question, where are my data? 10 people whispering to themselves. Did you hear any of them? Somebody shout up. Where is my data? It's in memory. This is the data structure that is in memory. It's the data structure for that beautiful dialog over here. So the dialog has a parent-child relationship. We have a bunch of Q objects. Some of them are line edits, some of them are combo boxes. My data structure is that parent-child relationship. What I see over here in my tree view is just a representation of that data structure. My model will be the glue that makes that possible.
Right. So we use the existing data structures in the Q object hierarchy. We don't copy the stuff over again into our model.
OK. So why don't you kind of start the? We will have Volker type in the solution. So start up the code for that. Okay. The handout for this exercise.
I'm trying, but it's black again. Oh, there's not much existing code already.
There is not much. There is a Q application. There is my beautiful dialog, which is a just a Q dialog, and I put something together in Qt Designer that we are setting up there. Then we have a tree view. I resize my view. I show the view. I haven't even specified a model yet. That is what those lines commented out are doing. Let's just comment them in. The view, set model, and the object browser model. So now I'm creating an instance of a class called object browser model. That class is what Volker will show you that he can implement in 2 minutes up here.
OK, let's try that. New plus.
So what you can't see is that Volker created, there we are. He's creating a...
next dialog is over here again.
And wrong screen. He is creating a new class. That new class has a header file called object_browser_model.h and a CPP file, object_browser_model.cpp. And its base class is QAbstractItemModel. Remember, the only way we can get a tree model is by subclassing QAbstractItemModel. Volker, being the perfectionist, says, no, I don't want this solution added to Git. That's OK. We can just delete it afterwards, Volker. And okay, here is our object browser model. This is a code generated by Qt Creator. Let's compile this.
Okay, let's see if that works.
This is a new development technique that I have invented. Compiler encoded programming, whatever my compiler complains about, I'll implement. Oh yeah, can you bring, okay. So what you can't see, we have different monitors. The compiler is complaining about 4 things. Number 1, well, it's complaining that it doesn't know about this QAbstract or this object browser model, so let's better include that.
Well, if it would come to the...
Next error, after running the compiler again, it will complain, you are creating an instance of a class object browser model, which is actually a subclass of QAbstractItemModel. You did not fulfill what you promised, namely to implement these virtual methods. What are the virtual methods? You're getting tired. It is row count, it is column count, it is data, it's index, and it's parent. So Volker will implement these. In your main. Whoa.
Oh,
that is going to be interesting. I think we need to talk about your salary again, dude.
It's just it's not updating correctly. So see, I'm actually in the right place there.
Could you return an integer?
Yeah.
So row count, column count, data, returning a Q variant. We have an index, returning a Q model index. And we have parent returning a Q model index 2.
OK.
Let's try and compile and see if our compiler is happy about us. Well, did you actually add them to your C++ file?
No, of course not. You said I should compile. So let's implement those.
That is bound to else enter.
What?
Carry on.
To what? Alt enter?
Alt enter. The
okay.
You place yourself on the and press Alt enter, and it will. Okay. Aha. We have the same key binding in Excel. That's why I know. So now he's implementing these 4 methods, and of course the implementation needs to be a bit more than just getting them in there. So let's start with column count. Can you bring up the solution again?
Yeah, maybe. Yeah, there we go.
There we do. How many columns do we have? 3. Does that depend on the model index? No. That's actually a pretty weird API if you ask me. I have never ever seen a single, have you? Seen a single implementation where the column count was using the model index for anything? Just say no.
No.
Thank you.
The problem is that Qt view actually only looks at the top-level column count, so no matter what you return there, it will just not be visible in any way.
And our beautiful implementation says return 3, just in case that you were.
Oh. I hate this thing.
OK. The row count. How many rows do we have? Actually, could you update your constructor to take the
Right,
widget?
that's a good point.
So go to your main and show that it's being created with that widget.
Right, there we have parent.
OK, could you do the?
Oh,
Yeah, so we have a special version of Qt Creator that has a separate window that we can show here, so he can see stuff on his screen too. Created by one of our coworker, Nicola. Nicola, it's broken. Fix it. So here's our main. We can see that the object browser model is given that dialog that I created that we are introspecting. It's given that in its constructor. So the model knows how to get to the real data by the dialog given in the constructor. So if you could just update the constructor code of your object browser model, and instead of the Q object pointer parent, just make that Q.
Well, Q object should be fine.
Q object should be fine. Pointer.
So you just need to store that somewhere, right?
Yeah, call it something different than parent. Dialog, underscore dialog, mdialog, whatever you like. So Q object pointer underscore dialog, m underscore dialog. That is now the dialog that our model is wrapping. And all our methods needs to access the information from that dialog somehow, because that is where our real data is. And the constructor, of course, will now.
No, my version isn't updating anymore. Okay.
It will remember that. OK, so now our row count. How many rows do we have? Gee, that depends on where I am in the tree. So why don't you start implementing that, and I'll be drawing a bit over here. So imagine we just had a very simple user interface, not that complex one that I had up there. The simple user interface would just be a group box that had 2 children. And around this, these were sitting in a dialog up here. That's my underscore dialog that I'm painting you here. I would have a number of model indexes. I would have the topmost one, this one here, Q model index. The empty one, that one would represent the topmost one. I would have a Q model index representing the group box here. So I would have another Q model index, Q model index. And remember, they had 3 things in them. Row, that would be row 0. Column 0. Pointer, That's my internal pointer. That's the cap that Volker is capable. That one will be a pointer to that thingy here. So whenever I need to do something, I have a pointer straight to that group box.
Okay, so that's the part we have implemented so far. As long as we are at the top level, it's very easy. We just take the dialog that was passed in and return the number of children. So for the other levels, we have to figure out how to actually get to the object we are currently working with. And I think Jesper will get to that in 1 second.
So this will be represented, sorry for the Jesper ugly font here. This will represent it as a tree looking like this. And the blah here, of course, refers to this model index here. So there's an association between that blah text in my tree and the model index. And the model index has the internal pointer up there. What did you do? So first of all, his row count says that if the parent is not valid, which of these parents are not valid? This one. If the parent is not valid, we are talking about the dialog. So this is underscore dialog. How many children does this element with the invalid model index have? Well, as many children as the underscore dialog has. That's what you wrote? Underscore dialog dot children dot size. Yep. If whoa, you're ahead of us here. If the parent is not the model index, then it's one of these three. We have last one for down there. Then we will go and ask the internal pointer. That's what he's saying there. Parent dot internal pointer, get me the internal pointer, and then cast that to a. Remember, that's just a void pointer in there. So cast that to a QObject pointer. Just reorganize it. I won't mind. Now I have a pointer to that particular one. So that could be this one here. That is a QObject, and I'll ask for how many children does that particular QObject have. Okay, that's my row count.
Okay. Next one.
Next one, let's try the data.
So we need the same separation again between we are at top level. Well, we are not at top level. Well, we are at top level means it's not valid. So the object we will be looking at is, no, wait a second.
He has implemented this in class like at least 20 times by now, and still he goes like, wait a minute. Thanks for showing how difficult it is.
It's actually easy. So
there we are. Otherwise?
Right, so we have no valid index, then we are looking at the top level one, which we won't see anyway, so it's actually pointless. Else we will be looking at whatever is in index.
So now I have a model index here that represents this boo down here. I need to know what text do I want to play or show here. So I follow my internal pointer up to boo. And if you could go back to the running example.
The running example.
Because what is the text that I'll be showing? Well, I'll be showing, you can see here, I have 3 columns. I will be showing, up there, camera. We'll be seeing 3 columns. The first column is the class name, so that is Q object. I will say metadata pointer class name. The second column, that's the object name, so that's just my Q object pointer object name. And the third column is where this is in memory for whatever reason I want to do that. So that's printf or whatever. I was just about to ask if you forgot about that one.
Or should I forget about that one?
That's okay. So remember, if we forgot this check, then the viewer would ask us, is this cell one of those that are checkable? And he would say, blah. And okay, I take that as a yes, and then all our cells would be checkable. And he's just showing off here. So, first of all, while he's typing, let's just review what he did. So if the index is not valid, that means it's this Q model index parenthesis open parenthesis close. If it's not valid, then we're talking about the dialog. And if it is valid, that would be this one, for example, then the children that we're interested in is follow our internal pointer up to that one, and then we're talking about that object. And next thing is to go and ask for, so now he has a Q object representing the object that we're really talking about. And now he needs to format that. So he first checks whether the role is the display role. Then he checks if it's column 0, that's the first column. Then we will be fetching the meta object out of that object and fetch the class name out of that. If it's column 1, then we will go and call the object name on it. If it's column 2, we will take the memory address of that object and format that in a fancy way.
Okay. Oh yeah, one last thing missing, of course.
Had this been me behind the keyboard, I would have used this fancy compiler-driven implementation technique that I like, and I would have pressed compile from time to time. But Volker is not doing that for 2 reasons. First of all, this thing doesn't work until you are almost completely done with this. You have no idea, and I challenge you to go home and try this out, to put in some a breakpoint in all the different places there and see how Qt is calling into this. It's calling it in weird ways. Remember the show that we did with, can you give me the row count for the Q model index parenthesis open parenthesis close? Can you give me an index for that thing? So if I didn't implement the index method, I would never see anything on screen. It'll just crash on me. And the annoying thing, once you've done this a couple of times, the row count, the data, the column count, pretty easy to implement. And then you come to the index and the parent, and you can easily spend half a day just pulling your hair because you need to implement these 2 methods entirely correct, otherwise it'll just crash. A broken parent method, crash. A broken index method, crash. You'll never see anything on screen. And there's 2 different ways you can approach this. You can either just start your go to your main and simply call methods onto your model to just see, well, if I ask the row count for Q model index parenthesis open parenthesis close, will it at least give me the right thing? Will it give me an index for this and so on? And there is also a model test.
Right, there's you find that on, I think, one of the Qt Labs pages. It's a file called modeltest.cpp. You just add that to your project. You create an instance of that, pass in your model as a constructor argument, and it does all kinds of sanity checks on your model. So it checks if you navigate down the tree with index, you actually get the same stuff again if you do that twice, and if you go up again with parent, that's the same as you got when going down, and all the typical problems you might find in there.
And it'll crash.
Well, it asserts with some helpful error message on what's actually wrong. Just like the views and the internals of QAbstract item models. So when he says it crashes, what it usually does, it asserts with some more or less helpful error message on what is most likely wrong in your model.
Or it will crash in your model if you just did not check whether you had an off by 1 error and stuff like that. How are your implementation coming along?
Well, I'm still missing index and parent.
So index, that is the method that will, given a row, a column, and a Q model index parent, you need to return an index. You create your index using the create index method, and you need to specify a few things there. Row, column, that's the easy thing, and then you just need a pointer.
Yeah. So
you think that will compile?
Most likely not. So what we need there is a pointer to the object, which is the child of the object represented by parent, and row gives us the number of children we are looking for. So if parent is this one, and we look for the second child, so row is 1, we need to find this one as a real object, so in our internal data structure, and then put it into the pointer of the new model index. So how do we do that? First of all, we need to
start from the top again. And it's the same game that we do all the time. If it is the Q model index parenthesis open parenthesis close, or the one that returns is valid, returns false on that question, then we know which object we're talking about. Then we are talking about underscore dialog, namely the topmost one we had here. So he's saying if, whoa.
This is not going to work.
Need help?
Just a second. So
could you, so we can see everything here?
Oh, okay.
Yep.
Okay. So if it's not the valid index, which means we are top level, so we consider mdialog to be the parent object, and otherwise we extract the object in the parent model index. Since that's a void pointer, I have to use those ugly reinterpret cast things there.
Hang on a second. Let's just try to decipher this. We need to find 2 steps here. I need to fill out that. I'm creating a new one of these sheets here, a Q model index. It takes 3 parameters to create one of these, row and column, easy, and then the pointer. And the pointer is what? Well, that is the pointer to the real data structure I have. And I now have a pointer to the parent, so I just want the rows 1. So what he will be writing soon is that he has this parent, he will ask the Q object for a list of children, and then he will get the rows child out of that. But how did I get to that parent? Well, if it was the topmost one, this one over here, then I got to the parent by just going with my underscore dialog that my model, my whole data structure was represented with. If it's not that one, then I will go and ask the model, can you give me that parent pointer? And from there, I'll go and fetch the data out of it.
Something like that, right? So
yep.
After we have figured out what's the parent object we are actually looking at, we look at the list of children, extract the one at the correct row, and put that in the new index we are creating here. Of course, this lacks all the safety checks if we actually have that many children, but that should be fine here.
Let's go and implement that parent thing.
Right. But what we have seen so far is in each of those methods, you have to...
Parent first.
OK.
Parent first. Then we'll be doing that thing. I know exactly what you want.
I'm not sure.
The parent method is the one that when I have this model index down here representing this one, then I need a model index representing that one. So give me the parent for this one. And so obviously return, create index, row, column, just write row, comma, column, comma, parent object. Then we'll fill this in. OK, the column, easy peasy. The tree views doesn't really have the concept of rows. If I have something at the 5th column, ask for the parent, it's not like giving me the 5th column of the parent. It just doesn't need that. So column is just 0.
Right.
The row is, well, parent is easy. For once, the parent object is easy because I have a model index here. Let's take this one. I have a model index here. my parent object is just taking that model index, getting my pointer out of there, which is a Q object pointer. And I need the parent pointer for that. That's just, whoa. That's just a parent object pointer parent. That's a method on your Q object. So that's an easy one. However, the less easy one is the row. Which row are we talking about? We're talking about what row my parent is in its parent. So I need to go all the way up and find my grandparent, so I can figure out what row is my parent in its in my grandparent. Of course, that's the row that we have there for the row, 0, parent object.
So
and it's going to be interesting to see if Volker will get this right on his first try. It's always, see again, just like we had the other thing, if we have a model index that's the invalid one, then do this, otherwise do that. But now we're going upwards, so when are we going to stop? When are we going to return that Q model index? That's the interesting thing.
right, we have seen in all the other methods that we have those two cases, the one inside the tree and the one at the top. And you actually need to have that in each of those methods in some way or the other. And it's still missing here, right? So in case of parent object actually being the dialog,
so I'm standing here now. I ask for the parent object. The parent object is the dialog. In that case, I should return the Q model index, parenthesis open, parenthesis close, because remember, the invalid model index is the one associated at the top with my dialog.
and
Yeah, you just brought the other one over.
no. This is the real one. As you can see, we don't have the correct column headers, and it actually works on the first try. Well,
should we give him a hand for that? Come on. I'm amazed.
it even works when you open those, which is usually, once you get to the point that it comes up, the next thing that will happen is it crashes as soon as you unfold one of the branches, which usually indicates that you forgot one of the cases in parent or index. So the top level will work, but underneath that it will either crash or do infinite recursion. So
just to give you an idea of what monster you're facing here now, this example here is from the training material. A couple of years ago, we changed, so we give that dialog in there. Previously, we were a bit more adventurous. So the top level outside here was not the dialog. It was the top level of all dialogues. So in that tree, you would see one level above it saying this dialog 2 that you have over there. And you would see another one which would represent the view, the introspector there itself. So the topmost would have 2 children. And I have seen so many times in class this crash when they started unfolding. Why did it crash? Well, because the first thing that the student would do when he sees this is this. Zzz, click. And internally, the list of objects that Qt returns when I ask for the list of top levels, now it's not this one being, it's not this window being the first and this being the second. No, when I raise a window, the list reorganizes and my data structure underneath me has changed. Of course, I should have been, if I had implemented this real well, had this been production code, I would have had my ears towards the wall and listen on any changes that the real data structure underneath me set. So if I was listening to this, the list of of objects there better have emitted a signal or somehow told me, yeah, the children was changed. Had this been if you're going home and saying, hey, this is cool, this is just how we're going to debug our software from now on, go to our booth and check gamma ray. I'm not supposed to say that, but go to our booth and check gamma ray, something like this. And I hope that the model that Volker has in there is listening to changes, because we are actually introspecting a real running application. And if one of these fellows up there get a new set of children, we could dynamically, with a queue timer, add new stuff to our dialogue up there. And if we did that, we better listen to those changes so that we can tell our view that stuff has changed.
Right, and that's actually a problem with using the object tree as a data structure directly, because it doesn't have change notification on the same level of detail you need to implement a real model on top of it. So that's something to consider when designing your data structure you want to use in that. It should notify you about anything that changes, anything you use inside the model that could possibly break. Like we are now relying on the order of children in the children list, but there's no guarantee coming from Qt that this order will always be the same. And there's no notification if it changes. So your internal data structure better have some way of notifying you if something changes that's relevant for the model.
Before we finish this application, we'll make one more change to it, not adding header data. We can live without that. But we will make the change. We will de-QMLify Volker. He's been doing some Qt Quick stuff, and in Qt Quick, the way that you program is cut and paste, right? So he's been doing a bit of cut and paste. Well, he didn't cut and paste. He just retyped and retyped and retyped. I'm not sure if you noticed that, but he typed a bit of code a number of times. Can you make that thingy go underneath so we can see things?
I can try. There you go.
So he did this stuff with, if we are at the invalid parent, then do something with the m_dialog. Otherwise, go and fetch the internal pointer, extract that, and then that is the thing that you'll be doing.
Right.
Volker will be making a simple change now. But the change is something that you can take with you home. And please do take that with you home and make that the very first thing you ever implement when you want to implement a model view or model for tree models. He will implement a method that will go from this world and into this world. So he has a model index, and he will extract that thing. And that class, besides going and doing extracting the pointer, will also go and check, are we at the model index at the top? Otherwise, go and extract. Because with that implementation, all his code up there will actually be much simpler.
Right, we have isolated the different cases between top level and inside the tree in one single place instead of having that all over the place in all of our methods, because we really need that everywhere.
So if it's a valid index, meaning not this QModelIndex parenthesis open, then all he does is go and fetch this pointer. It's a void pointer. He reinterpreted cast it to be a QObject pointer because we know that is what we store in there. Otherwise, it is this one, and then we know we are talking about m_dialog. And there goes 4 lines of code.
And another one here. So.
Okay, while Volker is de-cut and pasting his code, and I'm sure he'll break it so it doesn't work anymore, so we won't run the example when he's done that. Let me just do a very short resume of what we've seen here with the model view. We saw the list and the table was pretty simple to implement. Row count, taking this Q model index, we didn't care about it. We just ignored it. We just told how many we had in our list. Data, checked for what kind of data you're talking about, so we don't get checkboxes all over the place. And then returning the data. That's all that it took to implement the simplest list model. The table model, column count, and then we were done with that. And now the tree, all we needed to do was to implement this extra two methods, the index method and the parent method. And as we said, they can be a bit tricky. It's a nice way when you do this yourself to draw small cards like this, pointing to your data structure, try to visualize your data structure. So in your brain, you can all the time go from here to here, and the going from one to the other helps if you implement this object from index or whatever you're going from the index to your real world data structure.
Right.
Any questions on this stuff here? We'll continue for another 25 minutes. Just any questions on exactly that implementation? Okay, let's carry on.
Okay.
Let's see the slides. Gee, time is flying. Let's just, let me just talk for a bit here.
You're doing that all the time anyway.
Yeah.
So, yeah, do that while I'm trying to get the slides back.
So we have a special class called Q standard item model. I don't know what is standard about it. It should have been called Q stored item model, I guess. But it's called Q standard item model. Q standard item model is a class where you give it your data. We've seen how difficult this was. Volker got it working in the first attempt. So obviously not that difficult, but he's implemented that particular model 20 times by now. Seen hundreds of people implement that particular model, so that's like kind of cheating. If you have a tree model, it might be Friday afternoon, you need to get home to your wife and kid and whatnot, so you're not going to do this exercise, and you just need to show something to your boss. That situation, you could just take a Q tree widget and just populate that with data. And you know what happened Monday morning? Your boss will say, that's awesome. Can you also, and also, and also, and also. And before you know it, you have a Q tree widget that has been completely done with stuff. And then one day, the boss will say, yeah, can you also have another view? It's the same thing, but just with this. And you'll say, damn. Had I just made that a model in the beginning, it could have been a proxy model. It would have been 3 lines of code and everything would be working. So here's the advice. If you do not have the time and energy and knowledge and whatnot to do the thing up here, go for the Q standard item model. It is a model where you give it all the data. Pretty simple. There is an example of it for a tree right on that URL. You have that on your keyring. Okay. Go and try it out. We will not do that now because time is running out. Try that out yourself. It is really, really simple. It's just building the data structure by giving it the data. Right. Then you can put a proxy model on it, and eventually one day when your boss comes and say, yeah, by the way, these 200 lines you have in there, they need to be 200 million lines. Then it's just a matter of taking that one thing and replace it with a real thing instead of having to do everything again.
And if you're used to the tree widget, list widget, table widget classes already, the API of standard item model is...
My model index exploded.
That's what you get for throwing it at me. Yeah, if you're used to the widget-based classes, the API is nearly the same as a standard item model. You create standard items that represent a cell or a row in the model, just like you create table items, list items, widget, tree items in those convenience widgets. So there's really no advantage of these widgets over the standard item model and the real views. It just enables you to use all the other power, like proxy models, which we'll be seeing in a bit. Also in combination with the simple API that copies the data into the model.
Carry on.
Oh, okay.
So that was the standard item model. Right. We'll now talk about proxy models.
Right, finally.
I promised Volker that he would get at least 10 minutes to talk about proxy models. So,
Right. So, well,
why don't you tell the theory? I'll be preparing game up here.
so we mentioned that already. Proxy models are, looking at it from the outside, are also models. So they have the same GeoAbstract item model-based interface. So I can just plug them in a view, same as I did with the model before. However, the source where they actually get the data from is different now. It's not my internal data structures anymore. It's now another model. And that enables me to do all kinds of interesting component-based modular designs where I can just have the stuff we just did, the complex tree model. I just implement that as simple as possible, just access to my internal structures, no transformations, no sorting, no filtering. It's complex enough that way already. And then I can add a number of proxy models on top that take care of sorting, that take care of filtering out the bits I'm interested in. I might even do some transformations purely for the view, like Excel-like marking negative numbers red. I can do that in a proxy model without needing to bother with all that in my source model. And everything I have in a proxy model is reusable. I can put that on any other source model that provides data that is, well, numbers in this example. So it gives me nice modular components I can put on top of my model without making the original model even more complex than it needs to be.
Can we play my game now?
Yeah, we can.
I need 3 volunteers here. I promise you it will not hurt too much. You, and you. Come on up here. Hurry. Time's running out. There you are. There you are, and there you are. Just stand over here. Come on over here.
So yeah, we have our source model that Jesper just populated here, containing a list of countries and I guess the number of population in there. And we now have a colorized proxy model on top of that will mark everything red that is, let's say, bigger than Germany. And what else do we have?
So we have, wait, hang on a second. Yeah.
OK.
Take one model at a time. We have a model over there. It's a simple table. The table is 2 columns, name of the countries, the population of those countries. You'll notice Denmark is actually 5.5. That's like when you ask a kid, how old are you? I'm 6.5 years old. So we are those few people, so we need 5.5. The rest of the places are over there. We have a model here. He's a proxy model, and we'll see how good he is at being a proxy model. And I'm a view, and I will be asking questions. So if you could move a bit ahead so you can see up there. I will be asking, first question, I want to draw exactly something over here in the view. And he's a model. Scared model, obviously, but still a model. His purpose is to colorize the data over there. So they will all be black, except those countries that have a population greater than Germany. So he would be making, where are we? US and India, they would be red. Silly example, more realistic example would be some data that was negative, you would highlight that in red. Here is the communication going on. Model, tell me, what is the row count? It's not on. Oh, well.
Not on?
Oh, it's on. OK, you can take that one. So he didn't answer me, of course. He asked the model, which is Volker. So ask Volker.
What is the row count?
My row count is 6.
The row count is 6.
So OK, I know there's 6 rows. OK, can I get the data for the the color for the row 0, column 0, this model index.
Can I get the color for row 0?
Column
Column
0.
0?
The color is black.
The color is black.
Okay, can I get row 5, column 0, model index this? Can I get the color for the fifth
Can I get
row?
the color of column 0, row 5?
The color is black.
The color is black.
No, it's not. You are a broken model. You're a broken proxy model.
I'm sorry.
Your chances of getting a job with KDAB is null with that performance, dude. What will he be asking? He will be asking the source model over there, how many people are in row 5?
Okay.
And he will know that there are 312. He will know that 312 is larger than the 81 in Germany. So, proxy model, how many, or what is the color for row 5, column 0?
Please tell me the number of row 5, column 0.
Okay, that's 312 million.
Better at least. Yep. So
Well,
the color is?
So the color is red.
Awesome. Let's add a bit more to this, this insanity here. Let's get our flip model onto the stage too. The flip model will now flip the axis. So this will give us Denmark, Germany, Sweden, France in the first row, and then on the second row we'll have 5.5, 81, and so on. Okay.
No, that's actually the
are.
wrong way around. But
Whatever.
you basically change row and column.
Yep. So what is the row count? The proxy model.
What is the row count?
No, you're changing. Let me paint that. So
The column number.
right. So you ask him.
Ask him.
For,
you
yeah,
ask me
you
for
ask.
the-
Well,
the
we are
row
a
count.
chain of
Okay.
proxy models, so you don't know about me. Your source model is this guy.
So you
More
ask me.
microphones. There we are.
Okay.
So you asked about rows.
I asked for the row count.
What is the column count?
The row count.
You don't know about me anymore.
Okay.
He is your view. To you, there's only him, and I'm just
Well,
I'm gone.
So what is the column count?
The column count is 2.
The column count is 2.
The row count is 2?
Awesome. You got a job here. I won't even go into asking what the color is going to be because these guys will be very... Can we get the filter Europe model up here? This proxy model is filtering out all of those countries that are not from Europe.
In Europe.
We can do that too. All the countries in Europe, if you prefer that. So only countries in Europe he will be answering me. So drums. Model, because I don't know that he's a proxy model. To me, he's just a model. You know where I said, Fred, can you sing it for them? Never mind. Model, what is the row count?
What's the country at index 0?
Yes.
Where?
The country at index 0.
Yeah,
Row.
What
Row
is
0.
What is the country in column 0?
What is the country in column 0?
Denmark.
I think
Okay.
they meant road, but hey, it's
row 1, row 2,
it's late in the
etc.
afternoon.
Yeah. I'll have to go through all the countries.
You have to go through all the countries. Well,
And
let
we'll
them off the
have
hook, shall we?
Denmark.
But notice
1,
here.
2, 3, 4. The answer is 4.
Did he just circumvent them? Very optimized model. But notice here a key point about this proxy model. That this proxy model was now, when I asked a simple question, some of them, over here, my good colorized model, he's cheap. Sorry. I'm glad there's only guys up here. I would be sued for it. He's cheap. Row count, column count. Color, he does a bit of logic here, that's all. While this guy over here, he's, how hard to get. He's expensive. He better do some good caching. So that guy, he needs to ask all the information down there before he can get something down.
Okay.
You got a pen?
So
Can you? We know India. They are.
data
There's going to be
change?
more and more engines, right? So can you just increment them a bit?
Data changed at row 5, column 1. That's a signal.
The color is red.
Good try. Good try. No, your model just emitted a signal. Your proxy model. You better take care of all the things that in your internal cache needs to be updated. You need to do stuff, and you don't have an internal cache. You are a very simple pass-through model, but at least you need to tell them down the chain. So you need to tell them about that your data structure
Data changed 5.1.
So data change 5.1.
Did I change 1.5?
Yes.
Data change 1.5.
No.
And now I can go and ask, so what is the data at 5.1? And it'll hopefully in some way make it to Volker, and he will tell me the right thing. Please observe, though, that they had a bit of trouble figuring out their roles here in this proxy model world. But in the end, our friend over here, Colorize, it was a pretty simple one to implement. It was just going and asking for the data, and he would just ask on and then modify the data and return off. It's pretty simple. I can reuse him in my next project. He will likely be colorized and have a parameter with the number that should be colorized and some other parameters. Pretty simple one. My flip model, he's even simpler. Well, let's hope that we are only talking about tables. Flip model, if you ever tried that with a tree, what does that even mean? Don't go there. Our filter model, I'm sorry, but you're fired because we have one of you already in Qt. We have a Q filter model, Q sort filter proxy model. So we don't even need you. We just need an instance of that guy up there.
It only filters one column.
Can you do better?
Sure.
Okay, I'll take the microphones. Can you give those proxy models a hand?
I can take those.
And I guess that is concluding what we are going to talk about today.
I'm afraid
Proxy
so.
models, again, one thing, and they didn't even do it wrong. And damn you, you flip model. Because it's tempting, and we should have done it like this. He should have given, what was he telling when the data changed? What is the parameters? Data change signal. Q model index, comma, Q model index. And one thing that a model cannot do is to give out its source model's indexes. So now I'm the proxy model here. I get an index change here. I got an index. I'm just giving it on. What's the first thing that Volker will try and do? He will try and ask for the model that this index belongs to. And he thought that he would get to me, but now he'll get to that one. And Volker will do this thing that the other model up here did, just circumvent the whole chain and go straight down here. You've just found yourself a good way of terminating your application in a fast way, called assertion.
That's actually protected with assertions all over the place. And you will run into that when you call any of the model, the methods on QModelIndex, like this index and parent and all those. They just are convenience methods and call the corresponding model, the corresponding methods on the model this index was handed out from. So yeah, if he just passes it through, I will go directly back to the model, which might or might not be what.
And even if he didn't want to do something as evil as going to the model, he might at some point have forgotten what he was talking about, and he's standing with a model index, and he'll ask for, what row are you? And this flipping thing would be flipping row and column, but it just gave it on. So it was really the row which would have been the column which wrong.
Right. With the colorizer, it would sort of work, but I will bypass data and not get the color. But anything that changes the structure, like sorting, filtering, flipping, that would horribly break, because I would access cells that don't even exist in the sort model or widely off.
And on that note, congratulations, you made it through 6 hours of Volker and me talking up here. We are ready to take a final batch of questions if we have a microphone holder in a good shape of running. We got a question straight. I see my boss over there. I'm sure he'll ask a question about Excel.
Uh-oh.
I have a question.
Oh.
I have a question about QSQL relational table model. In a MySQL structure, you have 3 data tables with combined with a relational table. How can you use how can you fit the data out of the tables?
Well,
Only, of course, don't use a table view in MySQL, perhaps.
Well, there's built-in convenience models for SQL, like the table model and the relational model, and there's the generic one, the query model, which you can just give a complete SQL query. And the other two are quite limited, so especially if you have multiple joins, and you will hit the limits there. What you then can do is use the generic SQL query model, where you just pass in the full query as a query string, and then it will show you the results in one model.
But not with the possibilities with the QSQL relational table model, because when you change the inputs or the data in the model, they are written down in the data structure. And is it
okay?
Is it the same?
I don't think that will work out of the box with the query model, but you can add a delegate that understands the relation and actually translate the visible text into whatever you store internally there. But it's not. I don't think it works out of the box for complex joins in the SQL models.
Okay, I have to try it.
Okay.
Thanks.
Good luck. Other questions? This means I have a question.
Oh.
No, I don't. Okay.
Oh, there's 2 actually.
Sorry. Out of sight.
Hello?
Yeah.
Oh, okay, it works. Is there a possibility to do some threading, to do some asynchronous model readings? So if I have a big database and I want to read a few records, some from the middle, maybe it needs a long enough time, and my GUI application is frozen for this time.
Okay. I actually do something pretty similar in my thumbnail viewer in Kphoto album I talked about. I need to the user's doing like and suddenly hit a page where I don't have thumbnails yet. So I ask my model for an image for this given thumbnail, and rather than freezing trying to do that, I will ask my worker thread to actually get me that one. I will just return a pix map that is empty or with a question mark or whatever, indicating, yeah, I'm working on this one. And whenever my model or my worker thread have data for me, gets it to my model, I will know what that data represent, and I will emit a data change signal, meaning my data changed, which will make the view realize, okay, so you got stuff for this. By the way, it's not visible anymore, so I don't care. Or yes, it's still visible. Give me the data, and it will show that.
Well, there's one thing you need to keep in mind there is that you shouldn't really emit the change notifications of the model from the worker thread. But you have to use the mechanisms we saw earlier to get the results into the main thread and update your model there. Because the views, which are running in the UI thread, are connected to those signals. So it expects those to be emitted in the UI thread because you have a direct connection there. So
awesome. That's why it crashes all the time. great.
Right.
Oh, just kidding.
Um,
Did that answer
so-
the question? Good. We had another question right up here, right?
It was the same question.
Well,
It was
yeah.
exactly the same.
oh,
Okay.
same question. Okay.
Anybody
Okay.
else?
Final words. Those 7% of you, you know what to do now. Beer tickets? Ah, just kidding. Thank you for listening. Drop by our booth up there, KDAP, and have a great conference the next few days. Thank you.
Thank you.